and welcome back to Algebra 1. Today we are going to start into Chapter 4 content, which revolves around being able to solve equations and inequalities. Up through this point, we've dealt with everything called an expression, math problems that don't have equal signs and don't have inequality symbols. So starting today, we're going to start to look at how does our process of math change when we insert equal signs called equations and when we insert things like less than, greater than, less than or equal to, or greater than, which are our inequality symbols. So for today, we're going to start with our equations and more specifically what are called one-step equations, which is just a fancy way of saying they require one inverse operation to help us solve. So an equation is a mathematical sentence that contains an equal sign stating that two quantities are equal to each other. Or the sort of shortcut, simple way to think about it is I have an expression on one side, an equal sign in between, and a second expression on the other side. So expression, equal sign, expression. And if we have an unknown value called a variable in an equation, how do we go about solving when it requires one inverse operation is our goal for today. So how we go about solving one-step equations, no matter whether it's an add, a subtract, a multiply, or a divide. Go ahead here, hit your pause if you need to, fill in your blanks. I promise I'll explain as we go through examples here. All right, step one, where it says identify and box the side where your variable is on. That's an optional thing. It's not a graded thing. It's not something I have to show. It's just an organizational thing to help me focus on the side where I have to remove items or use an inverse operation to remove something so that I isolate or get my variable by itself. Remember, when you're solving equations, your ultimate goal is, in the end, I want my variable by itself on one of the two sides of the equal sign and everything else on the other. So I want to focus on that side with the letter and remove the other items that are on that same side. And the way that we remove those other items is using what are called inverse operations, or what you would think of as the opposite operation of what's given in the original problem. So our inverse operations that will help us today. If the original problem is addition, our inverse that we'll have to do to help us solve would be a subtraction. If the original problem is a subtraction, the inverse operation we'll have to do to isolate or get that variable by itself is addition. If the original problem is a multiplication, then our inverse operation that will help us solve will be to divide. And if our original problem is a division, then our inverse operation that will help us solve will be a multiplication. These are, again, one-step problems, which means they will require one inverse operation. And it should be a review of things that I did in previous math classes. So starting with if I have a one-step equation that starts with an addition in the equation, how do I go about solving? Using the inverse operation of subtraction. So number one, we want to solve that equation, p plus 12 equals 4. So your optional step, which is boxing the side where your variable is located, means I'm looking at this equal sign as my point of reference, and I'm thinking about the fact that there's some stuff to the left of that equal sign, and there's some stuff to the right of that equal sign. I want to find the side where the letter or the variable is located, which is over here in this one to the left of our equal sign, which means that P is going to stay in front of the equal sign as we work from step to step. But it also tells us I need to get rid of this plus 12 because in front of my equal sign, I want just that letter P by itself. So the way to do that is the inverse of what's there. So right now it's a plus 12. So our inverse would be to subtract with that same exact number of 12. And I have to do it on both sides of the equal sign. The way our step would look is I have an equal sign that's going to travel straight down the middle of my math problem. I bring down the problem that's there, which is a p plus 12. And then I need to get rid of this add 12. So on the same side, I need to do the inverse of the subtract, add, which is a subtract, with this same number, which is a 12. Now, what I just did on the front side of my problem, I have to do that same change on the back with our 4. And so I bring down my 4, and I have to do that same exact inverse operation so that equal still means equal. So we did a subtract 12 here, so I have to do that same subtract 12 here. Now, the reason we did an inverse operation of subtracting 12 is so that our 12s will eliminate, right? 12 minus 12 is 0. Those eliminate, leaving us with just our variable p left in front of our equal sign, which is what we wanted, the variable by itself on one side. On the other side, when we combine our like terms there of 4 minus 12, we'll get a value of negative 8, which is our final result here for p. P would have a value of negative 8. All right, let's try another. Number 2. We have an r plus 3 3/4 equals 5 1/8. Again, I want to focus on the side that has the variable, which is, again, here in front of our equal sign. I need to remove what's in that box with r. Right now, inside there's an add 3 3/4. So we need to do the inverse of this add with this number of 3 3/4, which means that we're going to subtract, and the amount would be a 3 3/4, and we have to do it on both sides of our equal sign. So to the left of our equal sign, we have an r plus 3 3/4. And we need to undo that add with a subtract, and the amount is 3 3/4. All right, what we do to one side, we have to do to our other side of our equal sign, so that equal still means equal. So over here, we have a 5 1/8. We also need to subtract 3 3/4 from it. All right, the reason we did a subtract here is so that our 3 3/4 will cancel or eliminate each other, leaving us with just this variable r, which is our goal. Get the variable by itself on one side. On the other side, we have a 5 1/8 minus 3 3/4. Right, we can combine those like terms to get our final result here of 1 3/8 for our value of r. Good final r in this case would have a value of 1 3/8. All right, number 3. We have a negative 34.7 equals a 16.2 plus m. For whatever reason, when we flip the problem, right, and now our m is over here, it's behind the equal sign. It's going to stay behind the equal sign. We tend to mess up our order when we go to do our inverse operation, so you need to be careful. So I'm going to start over here on the side that has m, because it's the side that tells me what I need to end up doing on both sides. I need to get rid of this adding with this number of 16.2. So our inverse would be to subtract, and the amount is 16.2. We have 16.2 plus n, and we're going to subtract our 16.2 from it. The other thing I could do is put this minus 16.2 right here, so that my like terms or my things that are canceling are directly next to each other. That is perfectly fine. Now, here's where we tend to mess up. On the other side, I want to do that same subtracting 16.2. I'm taking away the 16.2, not that 34.7 value. Right, so I'm starting with 34.7, and I want to subtract from it. The order matters over here. I'm subtracting the 16 from the negative 34.7, not the other way around, so be careful. All right, over here, 16 minus 16. Those will eliminate, cancel, whatever you want to call it, leaving us with just our variable m, which was the goal. Get the letter m by itself on one side so we know what it equals. On the other side, we would do our math, negative 34.7 minus a 16.2, which would give us a negative 50.9. All right, good final value here for m is a negative 50.9. All right, one more when we start with add. We have a negative 5 equals h plus negative 3. Now, the thing that makes this one a little bit tricky, again, our variable is behind our equal sign, so we have to be careful with our order. And also our number is a negative, which tends to mess us up a little bit. I'm focusing on this side where h is. It is behind the equal sign, so h is going to stay behind the equal sign. All right, over here we have an h plus negative 3. I need to undo or do the inverse of the add with this same exact number. I'm not changing the number. I'm not making that a 3. I'm doing the inverse of the operation, not the opposite of the number. Right? Those are two different things. So the inverse of add is subtract. And our number is this negative 3. So be careful. I'm going to have minus a negative there. So just be careful. All right, I got to do that same change of subtracting a negative 3 on the other side. Now remember, the order over here matters. I'm taking away or subtracting the negative 3. Means I start with the negative 5, and I'm subtracting the negative 3 from it. Order is really important here. That's a different problem than negative 3 minus negative 5, so be careful. All right, over here, a negative 3 minus a negative 3 is a 0, So those eliminate, leaving us just with this variable h. Over here, -5 minus a -3 would give us a -2. Good final value here for h then would be a -2. All right, let's look at, same deal. It'll take one inverse operation, but our original problem is going to start with a subtraction. Since our original problem now is a subtract, that means our inverse operation will be to add on both sides. So again, I want to start here by finding the side with our variable. Inside that block is going to tell us what we need to remove to get that g completely by itself. So right now there's a subtract, and the number is an 11 that we need to remove to get g by itself. So the inverse of our subtract would be to add, and the amount is an 11. So we take our g minus 11, and we need to get rid of that subtract 11 by adding an 11. All right, what we do to one side, we have to do to the other. So over here with our 16, we have to do that same exact inverse operation of adding 11. All right, -11 plus 11 would cancel, eliminate, leaving us with our variable g, which was our goal. 16 plus 11 then will give us our final value here of g is a value of 27. All right, number 2, we want to solve for the variable m when we're told that -6 equals n minus 19. All right, again, the order here is going to be important to us, especially since our variable is behind our equal sign. So it's going to stay over here behind the equal sign. Inside our box here, we have a subtract, and the number is a 19. So we need to undo subtract, and the way to do that is the inverse operation of add with that same exact number of 19. So we have n minus 19, and we need to undo with the inverse operation of adding 19. All right, what we do to one side, we have to do to the other. Now be careful, we are adding the 19 to what's already there. So what's already there is a -6, and we need to add the 19 to it. All right, over here, -19 plus 19 would eliminate, leaving us just with our variable n, which was our goal, get the letter by itself. On the other side, we can combine those like terms, -6 plus 19, we end up with a positive 13. Good final value for n would be that it has a value of 13. All right, number 3, 24. All right, again, we want to find our side with our variable, which is to the right of our equal sign here. We need to remove everything that's on the side with g so that we can get g by itself to know its value. So right now we have a subtract and a 5.4 we need to remove. And the way to do that is our inverse operation of subtraction, which is to add that same number of 5.4 to both sides. So our g is back here behind our equal sign. Make sure you keep that there. We're going to add a 5.4. All right, whatever we do to one side, we also have to do to the other. So with our 22.5, we also have to add 5.4 to it. Again, order matters. We're adding the 5.4. We aren't adding the 22.5, so make sure you have it in the correct order then. All right, equal sign down. Our 5.4s would cancel, leaving us with g by itself. And then our 22.5 plus a 5.4 would give us a 27.9. Good final value for g. All right, one more. We're told that c has a value, or excuse me, c minus 1/2 has a value of 4/5. So we're going to go in and try to solve for the variable c. Our c variable is over here to the left of our equal sign. So we need to do the inverse of what's in there with c to get it by itself. So right now there's a subtract 1/2, which means we're going to do the inverse of that by adding a 1/2 to both sides. So we have a c minus 1/2. We're going to do the inverse, which is to add that same exact 1/2. All right, what we do to one side, we got to do the other. So over here we have a 4/5, and we're going to also add a 1/2 to it. All right, cancel on the one side, we'll get c equals, or c by itself, which was our goal, and we'll end up with a 1. All right, do your 4/5 and 1/2, we'll end up with a 1 and 3/10. Good final. 2 steps gets us there. 1 for our inverse operation, 1 for our good final answer. All right, I hope that helps you attack your work for today.